So now, following this building which we have here on our screen, which is a live design which I'm performing for a client. Now, the client actually requested for a cost-effective design and all that, knowing that when we are performing a design of a structure, two things you have to focus on. One is the stability of the structure, and the other is the cost effectiveness of the structure. A good design must not be too expensive for the clients to afford while you maintain the structural stability. Now, on that note, I'll be using this building to perform or to carry out that with you. So on this now, you can see if I scroll back now, and then you'll be able to see the entire CAD file which we have here on our screen. Now, following this now, you can be able to see that this is the ground floor and all that. This has some kind of fanciful staircase. Then if you also look at this now, this is the first floor having a void through the living room. You can see that double volume. Then also you can also see the penthouse. Then let me now walk you through to the elevations or sections. So this is the front elevation of the building, which you can see here, having four designed pillars at the front or columns. Then also this is the rear, which is the back elevation, and then this is the right elevation, and this is the left elevation. Just fine. Now this is now the section of each of the build elevations following the views where they cut from the sections. So this is the section A, A1 and section A2. You can see the staircase here and all that. So one of our major goal right now on this building is to perform the design of the structure and also support this staircase and all that. So knowing that now, let's now move on to the structural design phase properly. So looking at this right now, knowing that the first place we perform our structural framing is to perform it on the ground floor plan. So on this ground floor plan now, the first thing I'll do, which is a culture here on Ekidel, and which I always advise as a culture, is to copy out the entire structural, the entire CAD file to a different location for it to have what? For it to have a duplicate. So right now, copy this now by typing CP and then click on any point here and then have a duplicate, let me say around here. So with this now, I'll be working on this particular duplicate, which I have just copied it out. Okay, that's fine. Now, while I wait for the system to respond, because currently we are like streaming live and all that, so it's like a bit lagging. Okay, so right now, once you have come to this phase now, the first thing I'll do is to make my ground floor plan, is to clean it up. All right. Clean it up simply means by removing the things that are not necessary on the building plan. Now, note that the features that this building has is a lift. You can see a lift here, and this is a residential building. So there's a lift here, which will make us to have a shear wall around this place, which is a lift wall, a reinforced wall. And then also there's also a staircase. You can see how the staircase looks like, and also a back staircase here. So I'll be showing you how to support this staircase, because knowing that if you look at the section here, you can see that this from the view here, this staircase needs to be supported on a landing around this place. So we will be showing how to support the landing of this staircase around it, because it is from different elevation from the slab level. Okay, that's fine. So right now, back to our GA now. On this GA, the first thing we'll do is to remove the dimensions. So by doing that, I'll just come here and click on this dimension and note the layer property, which is what this is showing, A anno dim. Okay, that's fine. So right now, I'll come here, highlight this ground floor, or highlight the both ground floor and the first floor, and then right click and then say quick select. So I'll come here and say quick select, and then allow that to open up, and then we will have to locate that layer property Alright, so come and click on layer, and then come and then locate that layer property here, and then we locate this. Yes, then let me see that again. This one here, and then click on what? Okay. Automatically right now it will pick just the dimensions alone, and I'll press E, enter. E means to erase. So with this now, we have just erased this dimension only on this copied one. You can see that we still have the dimension on the main original plan. Now, knowing the culture here, that if you want to, after this live meeting, I'm going to add this card file, the link to this card file, under this video description. But note, all our card file, based on trying to help people to follow up, is $1. That's the maximum. Okay, that's fine. So right now, once you've done that, the next thing now is to place your structural grid lines. Now, most times, architects that are very, very good used to place grid lines, knowing that most architects used to have a course which they go for, which is the structural course, which they go for later. So most of them has a structural idea, and they tend to perform their design for their building when they are trying to create a building plan, following the structural idea experience. But with that, we will have to also create our structural grid lines. But from what I'm seeing here, I can see that the architect has already placed a grid line, which I feel is a bit useful. So what I will do, instead of removing all these grid lines, I will make use of these grid lines that came with the building plan. But note that it is always advisable to have your own structural grid line. Okay, that's fine. Now, so with that now, since I want to make use of this particular grid line, what I'll do is to remove all these callouts, all these bobs for these grid lines, because I don't need them. I'll remove them, and also remove this other one here too. I'll remove this too. Now, I'll then look out for some grid lines that are not necessary. For example, let me look at something. I can see that there's a grid line here, which is not calling out anything. But let's see if it is calling out on the first floor. If it is, that means that there is a cantilever. Let's look at the plan again. You can see that there's a small, let me see again. A small cantilever is around this place, which is at the back. So that gives us the notion that this building has a small cantilever at the back. Can you see that? Okay, you can also see it here, a small cantilever. So with that, just to be sure, we are going to dimension the ground floor and the first floor end to end. So come here now, dimension this from this end. So from this end now to this end here, for us to check the overall dimension of the ground floor and the first floor. So we do this now, and this gives us what? 24,975 millimeter. Again, this also again, dimension this again from here all the way down to here too. Let's see, this is the first floor. Let me see that you're correct. Then let's see this. This is 26. So you can see that there is about 1 point something meters difference. Okay, that shows that there is a cantilever on this building. So with that now, we have taken note of that. Okay, that's fine. So again, I'll just move this dimension now. And then, since I have known that there is a cantilever, all right, on our left hand side on our right hand side of the building, which is this side, right, we will have to take note of that. So with that now, once you want to begin your structural framing, the first thing to do is to understand the building plan, which we have done now, to look out for the features. If there's a lift, where the staircase is, and if there's a cantilever on the building, what purpose is for the building. In this case, this is a residential building. That means that our life load or imposed load will be 1.5 kilonewton per meter square during our design. And our dead load, we are going to choose it based on the finishing load and partition load. Okay, that's fine. So with that now, we are then going to do what? We are then going to create two layers. Since we are using the software Protastructure for our design for this structure, we are going to create two layers before we can export this plan as our GA drawing into the software. So with that now, we are then going to create two layers. I'll type layer, okay, layer right now, and press enter key. So on that now, I will then come and then click on new. This place is to create a new layer. Okay, so with that now, I'll then click on this new here, and on this new, you can see that we have a new layer now. I'll then come and type grid, alright, and then choose a color. I can maintain the color which they have used here, which is this black color here, which is nice for me. I can choose to come here and then choose a color 8, which is gray. I'll come and choose the dark gray here and then press OK. Then I'll come again and create a new layer again. I'll click again here and then create and call it column. So this is just the two grid lines, the two layer property that we need to perform our structural framing. So with this now, I'll then come on here and then choose the color of that column layer. Come again, cancel this, and then come again here, choose this to be, I normally like to choose green, but based on this is a white background, let me choose red. I don't know if red will be okay. Okay, let me just choose dark green for that first to see, or red. Let me just choose red. And then I'll come now and then increase my layer property. Sorry, my line weight for the column for it to be more visible. So let me say 0.6 or something, or 0.7. I'll then come and say okay. So with that now, this is the two grid lines that we are meant to create, which is what? Sorry, I need to change this back. Sorry for that. Okay, this other one. Change this back to color this here. That's it. So now, once we have created these two grid lines, column and then grid, these two layers, I'll just come and do what? Click on what? Close. So with this now, since I want to maintain or use the structural grid line, alright, what I will do right now is to do what? I'll come here and then convert this axis to my grid line layer. Because right now it is still on the S grid that came with the plan, and we are meant to name it what? Grid. So I'll come again here, highlight this also again, and then convert these two now to grid line layer, which is, I'll come and click on what? Grid here. Okay, and I'll come here and make sure this is what? By layer, and this also by layer. All right, and then this also by layer. So with that now, it takes the property of what we set here on our layer properties. So on that now, we have created our grid lines. Okay, the next thing now we'll do, but if you don't have grid lines on the building plan, like what you do is to come here. Once you've created your grid lines, come here and then choose the grid, right, and then divide this line, this wall by 2, all right, and then type XL, enter, V, enter, all right, and then come and place your grid line at the center of this particular line you use to divide. So the whole idea is to create then once I've done that, then delete this one, which is to divide the line. Now the whole idea is to create a grid line on all the major walls. Now major walls are referred to as the walls which you feel you want to place your structural grid line. So your member for your structure. Alright? That's what it means. Okay, let me see again. So right now we are then moving on to the performing the column points and all that. So now on this, once you're done with your grid line placement, the next thing now to do is to begin to perform or to place your column points. Now placing your column points depends solely on you as a structural engineer. But what you have to do is that you have to follow the simple rules to placing your column. That's for your column placement and all that. So in that note, once I want to begin to place my column points, once I'm done with the structural grid line placement, I'll then come here on my layer to click on my to locate my column layer which we created before. So I'll come now and locate the column layer and then choose it. Let me just look at it right there again. This is it, correct, that's fine. So once you've choose your column layer, the next thing now to do is to begin to click and place your column points. For those people coming early on this live streaming, I say that this is a cost-effective structural residential building design that we are performing for a client and all that, and we choose to go live with it and all that. Okay, so with that now, we are then going to begin to place our column points. Now, to place your column point, it is required that the minimum column section is 225 by 225 millimeter. For those that understand inches, I simply means 9 inches by 9 inches millimeter. Now, if at all you want to use a lower column size, let me say based on width, let me say 6 inches block wall, and then you want to use a 6 inches column size, what you do is to use 6 inches by 450 or 6 inches by 350 at minimum. Okay, that's fine, but it's advisable to have your column 9 inch. Okay, that's fine. Now, to create our column, I'll be using rectangle to create column. So I'll just quickly click on rectangle icon or polyline. I'll click on rectangle icon, and then I'll click on this first point, and then hold on to this, and then click on this last point here. Automatically right now I have created a square column. We have column of different shapes: rectangular, circular, T-shaped column, L-shaped column, and different kind of column. But the first column size that should come to your mind is a square column. All right, and all that. So with this now, we will then begin to place this column based on where we feel we want to place our column points. So with this now, I'll just begin to place my column points around the major walls. The major walls are the point where 2 or more walls meet. So in this now, I'll just place this first one here. So I'll copy this out from here now, and then move to the next place here. Now, don't forget, I said that when placing your column points, as younger engineers, the column to column spacing, all right, the column to column spacing should at least be less than 6 meters or not more than 6 meters. Even senior engineers also use this principle, because what happens is that when your column spacing is more than 6 meters, it means that the beam spanning along that column or along that line will be also what, more than 6 meters. And when a beam becomes more than 6 meters, what happens is that the beam deflection on that beam becomes heavy, right? It becomes heavy because how beam deflects is based on the length. The more the length of the beam, the more the beam deflection. So it has been seen that from experience, once your beam distance, your beam span length is less than or equals to 6 meters, it means that you have lesser deflection on that beam. All right, that's fine. Now, when you begin to exceed 6 meters, for example, you are 8 meters span beam, 10 meters, you will see that you'll be having issues in deflection. So you have to design the beam against deflection. In turn, you will have to increase the depth of the beam a lot. So just to avoid that, maintain that your beam span or your column spacing be at least less than or equals to 6 meters. That will also help you when you are performing your slab paneling. All right, it will also help you on that too. Okay, that's fine. So with that now, I'll be placing my column point first. Then later, I'll now begin to look out for areas where I feel I want to add or remove columns. So I'll come now and place them. Make sure your columns are placed at the middle of the grid line, except you want the column to like flush, maybe on the left or on the right. But apart from that, make sure they are placed, all right, and at the middle. So I'll come and then place this one over here, and again, and then place this other one here. Okay, place this here. I will still continue again right now, and then let me place a column here. Let me see. Yeah, I want a column here. A column should be placed here, and again, I also place a column here. Later, we are going to check if we need to place more columns on some areas. So I'll come again now and place a column here, and then let me see again. That's fine. Now this one here is also a column, so I need to create a grid line first, horizontal grid line, to be able to find the center of that and then place it. Okay, so I'll skip this for now and then continue again. Place a column here and again place a column here. Okay, and then I want to basically place a column here. I'll tell you the reason why later. So I'll place a column here and then place another column here. So the whole idea is to place your column where you feel column have to be placed. Now you look out for the major structural points to place your column. I want to place a column here too, then place here, and again come here and place here. That's fine. And then I'll also place here too. Okay, so let's see what you have done so far. You can see what you have done so far. We are still far away to place our column point. So I'll come again now and then place this again here, and again I'll come again and then place. I don't have a grid line here, so I need to create a grid line here on this point, on this spot here, before placing that. So I'll skip that first and then locate again. Then let me see. I want to, there'll be a wall here. There'll be a wall here, a reinforced wall. So with that, I don't need to place any column points here because there's a lift wall that will run around this point here. Okay, that's fine. So I'll come again now. Let me place a column here, and again I'll also place let me see, a column here. There's also a grid line that will run here. You can see that no grid line is here. So I'll skip that and again come again now. Let me see. I want to place a column here. The column should be here, and again the column should be here. That's fine. And again let me see. Okay, I want the column here. The column should be here. Now you can have the CAD file later and then practice your own on that. Yeah, so also here, and then okay, let me see. There will be a vertical grid line here. I don't have it yet, so I'm going to place it later. So let me see again. I'll place the column. I'll break this span. It looks too big. Break and place it here. So I've broke this span, and again this span also looks too big, but let's not leave it first for now. And again I want to break this span too. It looks too big. That's too long. Break it. Okay, that's fine. And again let me see now. Let me see. So with this now, let's now begin to place grid lines on some areas where we don't have a grid line. For example, here we need to place a grid line at the center of this wall. So let's come now and type XL, enter, H, enter, and place this horizontal grid line here and play. Okay, that's fine. And I'll come now, and then once that is done, I'll convert this grid line to a grid line layer using match property. Okay, that's fine. Match property. So I'll take MA, enter, and then match this one here to this. Okay, that's fine. Again, now let's see again. There's still other places which we need a grid line. Let me see here. Let me see. Where is it again? We don't have a grid line around this lift here. So I'll come again now. Divide this wall into two first, like this, and then create XL, enter, H, enter, and then create a grid line here, and then delete this one here, and then match this MA, enter, and then click on this, and then click on this here. Yeah, okay, someone said it is breaking on the comment section. Yeah, maybe it's from your network, I don't know, I believe so. So right now we also create a grid line here too. XL, enter, divide this into two, and then click on this, and then divide this by 2, and XL, enter, V, enter, and then divide this, and then click on this, and then match it. Right, match this now to this. Okay, that's fine. So with this now, we have created a grid line around this place. Let me now see what we have done so far. Now with this, let's now go and place a grid line, a column point on the places where we don't have column before. For example, we don't have a column here, so place here, which is there's a need for us to have a column there. Also, a column should be here too. There's need for that. place this here. Okay, that's fine. So with this now, let us look at this now. Let's see. This span for me, this span looks too big. Let us take out this span length from here to here. What do we have? Consider we have 6.6 meters, which is for me is too big. So I want to break this span into two like this, all the way down. So that takes me now to copy this grid line CP, and then create a grid line at the center of this wall. Let me see the center of the wall, which is here. So I'll copy this now, CP or CO, and then from center point there, and place this at center here. Correct. So with this grid line now, I'll then place a column around that point. So I'll come now, click on this CP or CO, and then copy this and place this here. Okay, and I'll come again now, and then come and place a column here, but I'll need to shift this column to flush with the face of the line, like coming like this now, and then flush it this way. Okay, that's fine. So this column line is now flushing directly at the face of this grid. Okay, because of this opening here, we don't want this column to enter the opening. Okay, that's fine. So I'll come again now, and then copy another column again, CP or CO, copy this now from here all the way down, and then place this here. That's fine. Let me just reply. Okay, let me just do that for now, and then come again now. Then okay, that's fine. Let me see. A beam will run through this place to connect here, so I'll have to place a column here, else it will be too big. So I'll place a column here. Okay, that's fine. So again now, I'll then come again. I need to create, let me see this place. A line need to be here, a grid line here, or at this point. So I'll divide this line again by 2, like this. Okay, and then XL, enter, V, enter, and then click on this here and remove this one. So again, MA, match property, match this to this. Okay, and again, I'll now do, I also need a let me see, do I need a grid line here? Yeah, a grid line here. Okay, so I'll divide this again by 2. Now I can see why we need a structural grid line. And even we took time to create our structural grid line, we would have known that we have to place column points around this area. Okay, so I'll come again now and create this here, remove this now, and again MA, enter, match this now, match this to this here. Again, I'll then come again, and then okay, then come again now, and then let me see. Okay, that's fine. Everywhere is okay. So I come here now, and then click on this place, copy this column point, and then copy these points from here, come here and place my column here, and again come again here. Let me see these points here. I need a column is it here or here? Let me see how I want this point to be. This panel will run. First of all, let me put a column here first. Put a column here, and again put a column at the end here. Okay, let me see. That's fine. And again now, I also need a column. Let me see. This beam goes to connect here. Then how do we form this panel here? Okay, this beam can go all the way from here to span here. I can choose to add a column here. Let me see. Sorry, that needs to be taken care of. You enter. Go back there. Put this a column here, and then make it to flush. That means that this grid line is not at the center. Let me see. Okay, it's following the wall. So right now I'll come out and flush back this column to flush with the wall, because every column is meant to hide inside the wall. So I'll flush this like this now. That's fine. And again, I'll then come again now, click on this, copy this column, copy this now from here, and then go all the way down. And then let me see, I want to place a column here. The column should be placed here. Yeah, I think that's okay. So I'll place a column here at this point here. Okay, so I'll come now and then place a grid line first on this at this point, So SL enter, V enter for vertical bid line, and I'll place this here. And I'll press MA enter and then match this to this. Okay, that's fine. So with this now, I'll then copy this one. All right, copy this from here all the way down here. Okay, place it directly here. Okay, that's fine. So with this now, we have then from this one, let me see. I need to create a grid line here because of this. These two panels is already up to 30 square meter. You can see this is 23 and this is almost 29 square meter. So let me just break this panel with a beam. So I'll place a grid line here. Yes, it's okay to leave it as 29, but let me just break that. So I'll just come here and then click on this and then type XL enter, V enter, and place a grid line here. And make sure you convert it to a grid line layer. I'll remove this one, then MA enter and match it. Match this to this. Okay, that's fine. No need for us to place any column here because we can just, this beam can just support itself on the beams which we have below them. So let me now check the distance between this column to this column point. What do we have? Let's see. 5 points, correct. Now know that we are performing a cost-effective design, so we are going to use less columns, but even at that we will still make sure that the beam span is not too big, because if the beam span is big, it will affect the depth of the beam, which will increase more than 450 or 600. So with that now, we are still going to use the same principle of cost-effective design. So again now, we have then done this now. The next thing that we'll do, let me look at now, is to now, let me see, now look at the places where we need to add more columns or remove columns. Now let's look at this now. Let's look at the distance between this now and this column here. Let's distance. We'll have it 6.4. So I'll leave this column here. Again, let me look at this from here to here. What do we have? 8.7, which is very, very massive. So I need to find a way to break this span by adding a column at the center of this span. So with that now, I'll copy this column here. I'll copy, all right, from the center point again. Center point, make sure center point. Okay, and then come now and place at the center of this. Let me just place this here. If I place this here now, I need to flush it with the wall, because right now it is going to encroach into the window. Okay, so I'll move it back and flush it with the wall. This flush, that's fine. Again now, I'll then come again. Let me see now. So by doing that now, let me see. I can choose to move this column to flush, to have the same alignment with this other one, which we just did above. So I'll move this now and flush this here. That's fine. Okay, that's fine now. So with that now, let's now look at what we have next. Let's just see. Okay, so we have this now. You can see that. And then let's see the distance between this column here. I feel it is too long. This column and this column here. That will be long. 7.5 meter, which is too big, right? Too long for the span. So with that now, we need to divide this span by 2. I'll divide it from this point here. So with that, I'll come here and create a grid line here, and then XL enter, H enter, and divide this. Look at this point where it means that's the middle. Then take off this and then MA enter, and I'll match this to this. Okay, that's fine. So with that now, I'll need a column at this point and also a column at this point here. Okay, and also, okay, that's fine. Then I'll come now and then copy this CMCO enter or CP enter. Copy this now into this place here. Okay, so right now this is now less than 7.5. Also, we also have this here, because this is also longer than 7.5. So I'll come again now and then I'll insert a column here. There's a place here. Correct, that's fine. Here. Okay, so with this now, we don't have this, having this now. So let's now look at the game which we feel that is too long. Let me see. Let's see this distance here. I believe, but I believe they are less than 6 from this point now to this point here. To this point here. This is 6.05. I can choose to allow it. Yeah, 6.05 is okay. It's almost 6 meters. So I will just leave it the way it is without putting any beam here. Just that this the reinforcement here for this beam at minimum will be 4 diameter of 16 downward. There may be 3 up or 2 up. Then this one here, since it's having slab, okay, it's having slab only on one side because here is a void, here is a double volume, so they will still have the same reinforcement. This and this will have similar reinforcements. Okay, 4y16 or 4016 maximum done, and then 2 or 3 up. Okay, then again let's see the rest. Everywhere now becomes okay. Okay, so we have quickly done. Let's look at this distance, this one here. Okay, this distance, let's see. So from here now, let's see from this point to this point, what do we have? Let's see that we have 7.2 meters. So we need to break this point now with a column by adding a column at this point. Okay, so I'll copy this now, copy this this into this place here, keep this here. That means this also will also be divided. Okay, no, there's a wall here, so we don't need to put a column here. This is a lift wall, so we have to add a lift wall here later. So we don't, that one now will serve as a column. Okay, so we don't need that. Again, now let's see. Okay, that's fine. That's okay. Now we now need to explode this plan, okay, for us to see it on our software. Right now, you can see that most of the things are being blocked. So we need to now, don't forget, we have a column here, correct? Let us add it now. There's a wall here which will be carrying, you can see what's happening here. It will be carrying, you can see this is the wall. So there will be a column that will run there. So let us hide a column inside that place, inside that wall. So which is this here. So let us create a grid line now on that place. Add this here and then MA, enter, match this to this, and then create a column on that particular place. So create the column that will fit inside this void here, inside this shape of the wall. Okay, and also a column here too. So I'll create a column here too, like this, and again like this. That's fine. So on this now, we don't have now. If you look at, we have circular columns, right? Circular columns are on the front of the building, which is the entrance of the building, and you can see the columns here. So we need to also model that column as circular column, as using column layer to model that column. Else it will not show on the software. Now before we put that, let's look at the diameter of this column. Then that we have several lines here. So this is the actual column from, let's see, from here to here. The column is actually 350. So let's see where 350 is. So here, yeah, 350 is the diameter of the column. That gives us a radius of what? Of 175. Yeah, 175, correct. So with that, let's now go and insert a circular column on that place. Circular column here of diameter 350, correct. So with that now, we need to find a central grid for these columns. For example, this one now is not directly at the center, so we need to find a central grid. So we have to move this grid to be at the center of these columns. Okay, that's fine. So with that now, let's see how to get that. We need to first form, let me just see how, okay, I'll do that now by dividing this first by 2 like this, from here to here, and then create or move this grid line to the center of this red division line. Let me see the center. Where is it? This here, correct. So I've then remove this one now, correct. So with this now, let us create our column here. So I'll type C, enter. That C is for circle. So I'll come now and click at the center of this, and then they ask me to type the radius. So I'll type 175 and press enter key. So with that, now this now becomes 350 diameter what? Diameter 350 diameter column. Okay, that's fine. So I'll copy this now. I'll copy this, CP or CO, copy this now at the center of this, and begin to place it at the center of each of the column points here. That's one. Again, we also have the next one. Now this is not centralized, so I need to centralize this column, but let's see first. Let's see. Okay, a beam will run that directly through this grid. So let me just leave it the way it is. So I will do something like this. Let me see how other ones have been placed. Let me just see. Okay, I will copy this column now using the reference points from this. Okay, and then move it all the way down here. So you copy to it and then keep this here. Correct, that's fine. And I'll do the same thing again for this other one too. Copy this column from a reference point here, and then move it, or sorry, copy it to this other point and then keep it here. Yeah. The reason why I did this is because that this grid line will serve as a roof beam center, right, between this column and this column here. Else, if you click another grid line here, you can see that the roof beam will not be transferring its load directly at the center point where we'll have this column inserted point. Okay, that's fine. So with that now, let's now look at what to do again. So with this now, we have taken into consideration all of the column points. Now, note that from our first floor, there is a void. Can you see that? A void is over this place. So just to add that up, I'll come here now, copy this void, and then make sure I locate that point. So I'll come and click the lift, which is the reference point here, and then come again and let me see that. Is that place? Is that place? Let me pick the inside points. Click here again, click here, CP or CO, locate this point here, copy this here, and then come here and locate and add this up here. That's fine. So this now becomes what? There is a void around this place here. Now if you look at what we have here, at the end of this void, there should be a column here. Exactly. So with that now, we already have a column here on this other end, which we have, you can see it here. So we need to also put a column on this other end here. Yes, that will be better because we are going to have a cantilever slabs around this place here, around this walkway, around the slab here. So we are going to have a column here. So I'll copy this column now, CP or CO, copy that, copy this. Now someone else can choose to do a different thing, but I want to put a column here in my own case. So I'll put a column here, then I will escape now. So with that now, let me look at the distance between this column here and this new one we just added now. This is 5.7. I can choose to remove this column here, but let me just leave it. Okay, so right now, let's now look at what we do now. Then let's look at now. We also copy this particular walkway line, because this is a walkway here. After the walkway, we now have what? We now have the void. So I'll copy this walkway line and direct it to that place, because we need this for us to be able to know where the void actually is. So I'll copy this now and move to the first floor area. Let me see that. Okay, so now you can see that this is where the walkway is, where the beams are. Okay, that's fine. So you can see where the walkway is now, where the beams are. So that's okay. So no need for to copy that again. So this where these beams are now, these beams here, and here, we have the walkway there. Okay, which is this point. So now we then move to paneling. So I think it's already clear. So let us look at the paneling now. This panel here seems to be too big. Okay, seems to be too big. So right now we will be divide because it's too big. For example, this now for paneling, the area of a panel must not be more than 30 meter square area if you're using a solid slab, right? The reason is because when the panel, when the solid slab panel is more than 30 meter square area, it causes deflection, right? Or you have to increase the depth of that panel of that slab to 175 or 200, and most clients don't like that. So try and make sure that your panel area is less than or equal to 30 square meter. So with that now, if I check this now from this span to this other span for this panel, what do we have? We have 6.6, right? 6.675, right? And then again, from this to this again, let me see that, to here, we have 6.075. So again, 6 times 6 is already more than what? 36. Is already 36. So you can see that this value is already more than this panel alone. This panel area is already more than 30 square meter. You can see 38 square meter, which I don't want to use. So I'll have to do what? I'll need to divide this to place a secondary beam or internal beam through this place here by adding a beam here. So I'll come now and add this. I want this thing to flush together, so I can choose to actually have my column placed at the middle of this grid line. They should be able to adjust their void. Yeah, and after all, what I'm taking from the void is just 125. Sorry, 1.5. So they can choose to adjust this void backward. So I need my column to be here. So I'll come now and then extend this. Now this is now the beam which I'm introducing, not a wall but a beam. The reason of doing that is to divide this slab panel. Okay, that the reason of doing that. So I'll divide this again now by coming here, place this here. Okay, so I'll have to change the color of this grid line now. Let me just choose this beam. Let me just choose it to be that green. I think green is nice. Let me just choose this, and then no, that's not nice. Let me choose magenta. Then I'll just try to increase the line a bit. Let me choose this. So with this now, once we see this magenta line, it means that it's a secondary beam we are introducing, right? So with this, we have now divided this panel into two. So we have around 15 point something and 15 or 16 point something square meter now on each of these. Okay, that's fine. So again now, let me see again. We now look at this bar. I want to use here as a full panel. I'll ignore this dot. I'll use a slab hole to create this dot here during our design. So I'll just ignore that, and then I'll do it like this now. Okay, that's fine. And again here, just click on this and remove this one. Remove this and then click on this and then extend this a bit to hit here. Okay, that's fine. So right now, let's look at this whole bar area. You can see that it is what they say is 21 square meter, but let us confirm that first, if that is correct or not. So from here now to here, yeah, sorry, yeah, I've seen your comment. You say we should enter steel design. Yeah, we'll be doing steel design next week. So this is 66.675, and again, what's length from here to here is 3. So yeah, correct, because 3 times 6 is 18, so this will be around 21. So this is less than 30, so this will be a one panel. All right, this will be a one panel. So I'll remove this furniture symbol here, symbol for this and for this, enter. Okay, that's fine. So again now, we then have this panel here. This is 9 square meter, which is okay for to be a panel. That's fine. Okay, that's fine. And again, let's see now this particular panel now, as you can see the shape here, they say is what, 37 square meter. So what do? I'll need to introduce a beam from from here to here. All right, and again a beam from here to here. Now this beam will not have anything like block wall. It's just a beam to separate a panel. Sorry, that's not correct. Make sure the line is correct. And again, MA, enter. I'll match it now to our internal beam color. So I'll come again and click this and then click this. Correct. So with this now, let me just move all these furniture symbols here. So again, I don't want this curve, this recess here. I want to have this being crossing like this, so I'll just extend this being like this and extend this too, and then remove this stuff which I have here. I'll remove this and also remove this. So with this now, remove this too. So I have my beam now extending into this place here. That's fine. Okay. So with this now, this panel here now is now less than 30. Because right now we have already taken this panel here into consideration. So we can choose to have this now as one panel. Let's see this first. Let's see what square area this panel that we just created now is, and then subtract it from the 37 that we have. This is 3.9. Let's just say 4 at approximate. Then again from here to here, this is 3.7. So 3.4 times 3.7, that's almost 13 square meter or 14 square meter. So minus this, that gives us around 15 plus 27. That gives us 22. So this is 22 square meter now. This particular area now becomes 22 square meter. Okay, that's fine. So again, let's see here. This is back of the lift. This is I don't know what's here, but I think this should be this is a guest bedroom. So this is like where you can keep something. So I'll just remove this and then click on this and extend this beam to cross. This beam will cross, and then this beam will cross also. That's fine. So with that now, I will ignore anything happening here. Remove these walls. Okay, that's fine. And again, let me see. A beam will let me just see what happened here. Okay, they say this whole area is 23 square meter, but I doubt that. I believe this area is 23, not this whole area here. But let me just confirm that. Let me see that from here to here. What do we have? We have 5.6 multiplied by from here to here. We have 3, that's 15. So let me say 16 centimeter plus this. So I think it's true. Yeah, but even at that, I still want to have my beam cross this. But I can still choose to leave it actually. Yeah, to have just the beam crossing this place. So let me just cross this with a beam first. Cross this with a beam here, a beam here. Let me explode this my lift so that I can be able to see it when I export it. I'll explode it and X enter. Okay, that's fine. Okay, that's fine. So right now, let me see. So this whole area, I'll have to place a beam here, from here to here, and then offset 225 from here to here, right? And then match it. This is now a beam which I'm just creating. So I create this now, and then do this, and then do this here. That's fine. So now we then have this as a small panel, all right? A small panel. I would have chosen to add it up together, but I don't want that. I want to have a framed beam like this. Okay, that's fine. So again, now we will take this now entire place as a panel here and then here. Let me explode this door. Okay, so now we then also have this also as a panel too. Here's a panel, okay, because we have a sit out. You can see that we have a sit out here. So that's that area. Okay, so we have this as a small panel. So we have this now also as a panel. Okay, that's fine. So I'll remove this and I can choose to copy something here and then I'll just place that and call it P or P something. Just call it a P. Let me just say P P1, which is panel 1 or something. Okay, let me just put that to be sure that that's a panel. P1 or something. Then say okay. So with that now, I'll match it now with a property. Okay, MA enter, match this now to this. That's fine. So with this again now, let me look at this now. This will be a small panel. Okay, a small panel here. So I'll just extend this like this, like this. Sorry, like this. Or remove this on here. Then click on this, extend, and extend, and extend. That's fine. I can take off this door here. That's fine. Okay, that's fine. Again now, we will have to create a beam here. A beam will be here. Now let me just create a beam here, because we need to guide this void, right? Separate the void from the where we have our slab. So a beam will run here and a beam will run here. But the question now will be, this beam length will be too long. The beam span will be too long. So let me match it first to our secondary beam property, which is internal beam. Now this beam now becomes, let's see the length. This is almost 10 meters or something. Let's see. From here to here, what do we have? 9 point something meters. This is very long. So what I'll do is to create a cantilever beam from this reinforced wall here. A beam will come out from here that will carry this beam. All right, I will offset 225 to have the thickness of that beam. So this now becomes our cantilever beam. Now what's the cantilever beam length? Let's see. From here, grid to grid, what do we have? 1.7, which is nice. Okay, so I'll have to create this, and then let me trim this now off. Trim this off. Sorry, you enter, and then trim this off. It means that this cantilever beam now is carrying this beam at this point. Again, I also need to create again, copy this cantilever beam now, and then also create another one, copy here, and then move again to this other place here, and then place this here. Okay, that's fine. Again, and then I will then move again. Let me see. Yeah, that's fine. And again, let me see. I need to connect this to make it to flow down. Okay, down. So this now, this two here, this one here, and this one here becomes our cantilever beams. Okay, so I'll have to trim off this now from here to here. So with that now, we are now carrying this 9 meter beam with these two cantilever beams. So what it means is that this beam, this 9 point something meter beam now is now carried by these two cantilever beams. Okay, that's fine. So here becomes a panel, a panel, a panel. Of course, here will be closed. So we are going to create a door later on the model. So here will be closed with a reinforced wall to be closed like this. Then extend. All right. Then also offset downward. Then match it now. Here I'll match this to this. Correct. But this is a reinforced wall. Don't forget that. It's a reinforced wall binding here together. Okay, that's fine. So right now we now have this panel, this panel, this panel. Okay, and then all here to be void. So with that again now go again. Let's see. Now we are doing paneling now. You can see that we are trying to frame the structure. Now we are doing the framing of the structure. I can just to remove just extend this, extend this, and extend this. That's fine. So now again, let's now go to this place now. This place is 25 centimeters, which is okay. So I'll just extend this and extend this. That's fine. And again, let's see now. This is 8 square meter. If I add this to this, it's a more than 25. Sorry, more than 30. Yes, I would have combined these two as a panel. So I'll just ignore that. Now look at how this place is being recessed. They can use a block wall to form this. Okay, so I won't be concerned about this recess here. Okay, but I say, yeah, this is a handrail, so I'll just throw my beams across this place, and then they can use a block wall to form this later. So I'll just ignore this recess here. Okay, that's fine. So I have my beam going all through down like this. So with that now, I'll have my beam here crossing here. Let me just leave that wall first, but I'll have my beam cross there. That's fine. So again, this is a duct, so I'll just ignore it. I'll use a slab hole, an opening, to create that to create that opening on the slab. Okay, that's fine. So I'll come again now, extend this, extend, and then remove this window line and extend again, extend this. That's fine. And then let's see. Yeah, a beam will run here. Now this is 56 square meter, which is too big, very large to be a solid slab, very large. So right now, let's now begin to look at how we're going to break it. Okay, to break that panel. Okay, no, let's now look at the shortest span that we can choose to add our beam. Let's see, from here to here is what? This is 7.5, which is very, very long. Let's now see from here to here. This 8 is very long. Now I noticed that we don't have a horizontal grid here, a grid line. This is bad, so I'll come and create a grid line here now, then convert it to a grid line. Come here, that's fine. Then now, because of this span length, I'll copy a column and place it here. So with that, now I can choose to bring a beam from this column to this place here, which will be around 6 point something meters, 6.9, almost 7 meters. It's still big, actually, it's still big, but I can choose to design, because there's no way I can be able to support anything or place any column around this kitchen. No, the client wants it to be open without any column, and you won't like it to have a column find at the middle of your kitchen. It doesn't really make sense. So right now, let me look at the shorter one. So from here to here, we'll have let me see, 7 point something. So I will take this as my beam to break this panel. So I will do something like this now, create an internal beam here just to break the panel, and again here. Okay, so this beam now will be deep actually, and the column that carrying this beam here, these columns will be big actually. They won't be this size joined it, but let us use the effect to like design for it, because right now we are just assuming the column sections. After our design, we will now know the actual section of the column. Okay, that's fine. Again, now let's see again. This panel also seems to be too big, right? It's already more than 30, so we need to also break it too. So I'll break it like this now, right? Break it like this now. So I'll come now and break this again. Let me see. I'll break this again now from here. Now you can choose to break your own anyhow you want it, but make sure they are structurally framed. Okay, so I'll come again now, come here and break this. So now again, MA enter, and then match this, match. Okay, that's fine. Again now, I'll then come again here, continue with this. I think this one seems to be a small panel, but I just need it to cross. Okay, I want to cross this thing. Yeah, it would be nice to cross this. So, but if I cross this now, I won't be using this again as a beam. So I'll remove this now as a beam. Okay, remove these two as a beam. Okay, these two should go as a beam. Okay, that's fine. And I'll remove this. Then I'll have a beam now crossing here. So I'll cross this now like this, from here all the way down here, offset 225. Then I'll come here, have this like this. Okay, then I'll have to trim off this beam because one of them will carry each other. So the longer one becomes the shorter one becomes the primary beam. So this beam now is what is carrying these two beams. So with that now, you can see how I have break this panel from being 56 millimeter to having 4 strips of panels. Okay, that's fine. So there will be a beam running here for sure. So a beam will run here, that's fine. And again, let me see that a beam will run here. Let me just put a beam here. A beam will run here, but it will not have wall load because this is like a window all through. So a beam will run here and 225, offset 225. Then match it with the beam that's not carrying wall load. So this beam that have this pink color will not be having wall load. Okay, that's fine. So again now, let me just see. So we have done this panel now. Okay, that's fine. Then we need to create a grid line here for this beam. So I'll divide this now into 2 equal parts, and then XL enter, V enter, divide this, and then remove this, match property, match this to this, that's fine. And again now, let's see. Okay, it's trying to save. Now, if you have any comments so far, let me know the comments you have so far. Okay, that's fine. And again, let me see now. We have this now. So again, let's see. Just explode this. That's fine. And then let me see this now. Now we then move to this other side now. This is that one here. You can see this one here now. It's saying 32 square meter. So what I will do now is to I'll need to first let me form a beam around this place. Sorry, yeah, that's fine. Then extend extend this, and extend this. That's fine. And again, let me remove this. I don't want to use this. Let me see that. I don't want to use this as a panel. Let me just remove, trim off this beam, this wall. Okay, trim off this wall here. Then remove this. Then remove this symbol for wardrobe. Remove this. Remove this. That's fine. And again, remove this here. So now I want to have. Let me see. I also remove this too. I don't want to. Let me see that. This panel is too small to have it as a panel. So I want to combine something now. I will have to throw a beam from this point to this column here. Right? Then offset the beam thickness 225. Offset. Then make it to beam that not carry block wall, because there's no block wall here. This is just used to separate this panel, to break it. So now I'll then remove this door here and this small beam that seems to have here, this small wall here. So this wall will just sit directly on the slab, which is smaller. So I'll remove this also. That's fine. So we now have this, okay, as a panel. Okay, as a panel. So this now becomes a panel. Okay. I can just also basically move this column to here. Okay, so I can have a panel like, because I don't like the way it is like this actually. So I'll move this now, move this basically. I'll move this now to here. That's fine, to here. And then I will now trim off this. So with that, I have saved this beam length, okay, from the cost of the building. So you can see. So the reason why I'm combining this is to save the cost of the building. You can see that. So I will also trim off this off. Then instead of having this beam here, I can choose to have it enclosed here, something like this. Correct, that's fine. So with this now, just trim off this excessive one that entered here. That's fine. Okay, so you can now see that. So we now have it now as a panel, and then this as a panel, and then this will just be a slab hole, which I'll create here, which is for a duct. Then let's see here now. Now this place now becomes less than 32 square meter, because this square meter was added to this. So if we check this now, length and width from this panel from this point to this point here to here, we have 5.025 multiplied by from here to here. This is 5.1. So that's around 26 square meter, which is less than 30. So this is now okay. This is okay now. So you can see that with this now, we have specifically done our structural framing for this. Now once you're done with your structural framing, the next thing now to do is to copy your columns onto the other floors to see how they will appear. Knowing that this is one story building with a bent floor. So let's now copy the columns. So I'll click on one of the columns now and right click on it and say select similar. To pick all the columns that we have here now on this ground floor, and let me see, also the circular ones too. I also copy that, right click and say select similar, and then I'll copy from a good reference point, which is the lift point. So I'll copy it now from this lift point here, right, to the other points. Now the reason of doing superimpose is to see how the columns are going to appear, how our column points on the ground floor that we have done is going to appear on the other floors. Okay, that's fine. So you can now then also copy down. You can see how it is now. Most of the column points that we have are not appearing. Okay, that's because we have a cantilever. You can see here, a cantilever is here, and also a cantilever is on this side. Yes, a cantilever is on both sides. If you look at the building, I have a small cantilever here and a cantilever here. Leave it. And a cantilever here. Leave it door. And a cantilever here. So with that now, we are going to note the columns that will stop directly on the slab. We are going to change their colors to either green or something. Yeah, green is nice. So I'll come now and begin to change. These columns now are causing obstruction to the person using this bedroom tree here. So I'll have to do what? Change the color of them. That means that these columns will stop directly on the slab. Okay, so I'll come here and change it to green. Let me see. I think green is okay for you to see. Yeah, correct. So change it to green now. Okay, so I'll now do what? Match property. I'll match it now and begin to look at for the columns that are causing what? Obstructions. So this one too will stop at the slab. This one here at the slab. This one here at the slab because it's causing issue here. Again, this one too will stop at the slab. Here too at the slab. So what it means that these columns that are changing to green will not pass through the slab because it is causing obstruction on the first floor. So when we're on the first floor, we'll now look at for a way to support a column again that will carry the paint floor. Okay, here too on the slab. Okay, again here will stop, here too will stop. Okay, that's fine. Again, this one too will also terminate on the slab. Here also terminate on the slab. This one too also terminate on the slab, terminate on the slab. Then let's see again. This one too will stop on the slab. This one too on the slab. Here too will stop directly under the slab. This also. Yeah. So you can now see. Let me see that now. That's fine. That's okay. So we have here too under the slab. So now we have taken note of all the columns stopping under the slab. The ones that are passing through the maybe through the window, I can choose to stop it, or I will advise the person that did the drawing, right, to shift the window, at least they are on space. Although it will change his design a bit, but if there is need that this column must be here for this structure to be stable, then we will leave it there. Okay, that's fine. So again, let me look at again. This one also, they will shift this window off from this point, and because they have space here. Okay, that's fine. So again, let me now look at it now again. Okay. Although I can still stop this one directly on the slab. Okay, this column here on the slab, so that they will still have their window being placed. So at the first one, now we have to move this column on the first floor to this point. So there will be a cantilever beam that will run under the slab to this place here. Okay, that's fine. So right now, since we have done this now, the next thing now that we are going to do, let me see this one also. Here also, I'll change it also. This will also terminate on the slab. There will be a cantilever beam that will come from this column to this place that will carry the next column here, that will move from here to the paint floor here. Okay, I don't know if you can understand what I did now. Okay, so now on this now, let me now look out for okay, we have done this now. I can also terminate this because I don't want to change the look of this building, so I'll also terminate this now also on the slab. So I will have to shift this column to somewhere here on the first floor here. Okay, later during our model. So that's terminate too. Let me see if this is meant to be here. Yeah, correct. There's a block wall here on the first floor, so that column is still hiding inside the block. So that's fine. So again now, so we have checked for all the columns that are not suitable on the first floor. So the column points on the ground floor, most of them will terminate on the slab. While on the first floor now we now have to do what? Introduce a new column that will carry the paint floor. But look at it, the paint floor has a different shape. Not all the size of the first floor is on the paint floor. There are some places that are roof below. All right, you can see the roof below. So we are going to model. We are going to also copy the column points. Once we are done placing the column points, a new column points on the first floor, we are going to copy the column points and move it and check how they will appear on the paint floor. Now, once you're done with the column, let me now first of all remove trim off these excessive ones. Okay, so I'll do XL, enter, H, enter. Correct. Sorry for that first. Correct, and then come here and then place this here. Let me just place this around, bring it in again. Place this here and then trim off these excessive grid lines. okay, and then remove this one here. Again, XL enter, V enter, and then come like this and click on this, and then trim of these excessive ones here also. Trim of these excessive ones. This goes. Again, delete this. Again, XL enter, V enter. Again, come here, trim off these excessive ones here. These grid lines, trim them off, and again, delete this. And again, XL enter, H enter, and again come here, remove this one here, and trim this off, excessive ones. That's fine. Again here, that's fine. Then now you delete this. So with this now, you can see that we have now successfully performed a GA framing or structural framing for this ground floor layout. And we have also identified the columns that are going to terminate on the slab on the first floor here. Now, before we move to the paint floor, because we need to make sure that we have done structural framing for all the floors, and we have known how we want to support each of the floors before we can now move ahead to the model. You can see that we have spent more than 1 hour plus on just structural framing. That's because to show you how important structural framing is. Now, when you're performing a design of a building or a structure, it is during the structural framing you are actually doing the real structural design of that structure. Because if your structural framing is wrong, your modeling and your design will be totally wrong. They will fail. Okay, that's fine. So right now, before we move into the next part, which is to do a column framing now for the first floor that will carry the paint floor, because the paint floor and the first floor plan is not the same. So we have to do a framing again for the column on the first floor that will carry the paint floor. Okay, that's fine. But before we go on that, I'll be going for a break because I've talked for like 1 hour plus now. I'll be going for a break and then resume later shortly. Okay, that's fine. Now, please, if you have any comments, drop it down on the comment section. Why I will reply the comments while I'm on the break. Okay, that's fine. So thank you so much and God bless you. And also, please, the next section will be in the next hour, 1 hour. So please also invite your friends and colleagues that you feel that needs to learn this. Okay, that's fine. And if maybe you have a bad internet or network, you can just go and rewatch back what we have done so far. Now, thank you so much, Engineer Timothy. Yeah, thank you so much. I see you say good. God bless you. Yeah, thank you. And also Engineer Peter Anu. Yeah, thank you. And for everyone that are live here with us, thank you. And then see you on the next section of this cost-effective structural design for residential building. See you and then bye for now. Okay, and bye. Yeah.